Hello everyone. This is the third video in the series of Edexcel Statistics videos, and as I've mentioned even before, anyone who wants statistics knowledge can have this complete course of statistics. And this video primarily focuses on the statistical representation. I urge you that if you haven't watched the previous two videos related to sampling and statistical calculations, you should watch them, because without their understanding, you cannot move further, right? So let's dive into the topic. And yeah, okay. So in the syllabus and what we will be covering, I will post for each of these, I will post one video. We will be covering box plots, right? Cumulative frequency graphs, histograms, frequency polygons, and scatter diagrams. Now, box plots, they can be used with, a single variable and ungrouped data, when we do not have to see the effect of one variable on the other variable, right? Not in that kind of a case. It is used in a kind of a case in which, actually you have to compare maybe two groups, let's say females and males in a running race. It quickly shows you the median, the interquartile range, the quartiles, the range, right? And it is useful for comparing, as I mentioned. Then cumulative frequency graphs, they can be used for continuous group data of a single variable. It shows the total, the cumulative frequency, which fall below the upper bound of each class, right? We're going to discuss each of them further. Histograms, again, they're used with continuous group data. It can be used with, the good thing about this is that the class widths can be different, and it can be used with varying group sizes, right? It shows the frequencies of the group representing by the area of each bar, not the height, the area. Then frequency polygon, it displays the shape of, again, a continuous group data. You join the midpoints at the top of each bar of a histogram, right? We are going to discuss this even with histograms only. And scatter diagram, it can be used with ungrouped bivariate data, two variables, all of the above for one variable. This is for two variable, and it shows the relationship between the two variables. In this video, we will be discussing the cumulative frequency graph. Okay. Now, as you can see here, it actually shows the time, 100 meters time at the 2012 London Olympics, right? So 9.6 to 9.7. One person completed the 100-meter race in 9.6 to 9.7 seconds. So the cumulative frequency of the people who completed the race in less than or equal to 9.7 seconds is 1, right? 9.7 to 9.9, 4 people completed. Now, if I say the cumulative frequency of less than equal to 9.9 seconds, that would include the cumulative frequency of this also, because 9.7 is already less than 9.9, right? So this will be 4 plus 1, 5. Then less than equal to 10.05. Again, there are 10 people who completed between 9.9 and 10.05. If you want less than equal to 10.05, you need to add the cumulative frequency of less than equal to 9.9, because 9.9 is less than 10.5, right? 10.05. So 5 plus 10, 15. And then similarly, 15 plus 17, 32. These are the cumulative frequency, and your last cumulative frequency will always be equal to the total frequency. You should just know that, right? Okay. Now here we have the cumulative frequency. How do we plot them? Very simple. Your timings are on the lower bar. 9.6, 9.7, 9.9. So at 9.7, you're going to plot 1, right? Then at 9.9, you plot. This is how you get your cumulative frequency. Now here, why are you plotting here? It's actually being plotted here. You know that 0 runners, this is for 9.6, right? And this is 9.7. The scale is a little out. This is 9.8, this is 9.9, this is 10. I hope you understand, right? 10.05. See, that is why the point is over here. Okay. You know, at 0, runners had a time of up to 9.6 seconds. So the lowest cumulative frequency is always 0, right? So 9.6 is the lowest bound. There you will plot 0. You go up to 10.2, that is 32, right? Now, you need to estimate the median, lower quartile, upper quartile, and the interquartile range from the cumulative frequency curve. How do you do that? It's very simple. Okay. Median. Now, you have a total cumulative frequency of 32. What will you do? Median is the 50th percentile. So 50 upon 100 multiplied by 32, that is 16. So at 16th position, you need to see what is the value on the graph on the x-axis. You will check 16 on the y-axis. You will check the cumulative frequency and you'll see the corresponding x value. So as you can see for 16, the value is 10.07 seconds. Then the lower quartile will be 8. How? 25% of 32, that is 8. And at 8, you'll see the corresponding x value, 9.95 seconds. Upper quartile, 75% of 32. That is 24. And at 24, you'll see 10.13 seconds. Right? And then the interquartile range, how will you find? Upper quartile minus lower quartile, 10.13 minus 9.95, that is 0.18 seconds. I hope you understood this example because this is very important. I've explained you plotting and I've explained you how you estimate the quartiles. Now here, they've already made it for you and there are a few other kind of questions which can appear in your paper, right? So let's look at this. This is the cumulative frequency, number of values greater, smaller than. We are doing questions related to this. Estimate how many runners at a time less than 10.15 seconds. Now you will see, you have to see less than 10.15 seconds. Now, if you know, we have found the cumulative frequency in the less than position only. That if I go back and show you the table, T is less than 9.7, less than 9.9, less than 10.05. So you will simply look where is 10.15 and you'll simply take the corresponding Y value there, which is 26 runs. If it is more than, we haven't taken the values in the sense of more than. We are seeing the values in the sense of less than. Now, what do you have to do? You have to see in the same way, but you have to minus them from the total. If our table would have been in the way of more than, then we don't have to do that. But since it's not in the way of more than and less than, we didn't have to do that. But here we will have to minus. How many runners between 9.8 and 10? So that means more than 9.8 and less than 10. You need to find both. So more than 9.8, that is, you are again going to look at 9.8, you're going to see the value. And then at 10 seconds, you're going to see the value. And in between, you'll find the value in between 9.8, right? Which is, and 10 seconds. At 9.8, the value is 8. At 10 seconds, the value is 26, right? So, sorry. Yes. At 9.8 seconds, the value is actually 11. It's showing for the other question. It's showing for this 26 runners. So at 9.8, the value is 11 seconds. 9.8, the value is 3 seconds. And at 10 seconds, the value is 11. So 11 minus 3 is equal to 8. That is how you will find this value, right? So this was for cumulative frequency curve, and we will discuss in the next video, we will be discussing one other type of graph. Okay. If you have any questions, you can post them in the comment box or you can always WhatsApp us on our number. Thank you.